This is section 6.2, the sum and difference formulas. And we're going to begin with the sum and difference formulas for the sine, the cosine, and the tangent. Now, if you can look at each one of these and look for some similarities, as you can see, the sum and the difference of the sine, so the sine of a sum and the sine of a difference, they follow the same pattern except for the sign. So we have u plus v is what we're taking the sine of. And you can see that we have the product of the sine of u multiplied by the cosine of v. And now we'll switch that up, plus the cosine of u times the sine of v. So you can actually see a little pattern in there. Now what makes it different between the sine, sum and difference formulas, and the cosine? Take a look here. We have the cosine of u plus v, and we are going to take the cosine of u and the cosine of v first and multiply those together, and then the sine of u multiplied by the sine of v multiplied together. Now what do you notice? These signs are opposite, where those were the same. Okay? And the tangent, we have these beautiful quotients. So we have the tangent of u plus v and the tangent of u minus v. And as you can see, that numerator has the same sign and that denominator has the opposite of that sign. Okay, let's use these sum and addition formulas to find the exact value of some of these trig functions, okay? Trig values. So we'll begin, I'll try to keep this up there, the sine of 15 degrees. Now, when we are working with these, we would like to use the angles we're familiar with. And what are we familiar with? Well, we're familiar with 45 degrees, and that's equal to pi over 4. And, of course, we could go into pi over 12 with that if we'd like. Why don't we do that? That's 3 pi over 12. I'm mentioning that because we are seeing a 12 here. Also, how about 30 degrees? That's pi over 6, and that's equal to 2 pi over 12, okay? And so we have 45, 30 degrees, and now, of course, 60 degrees. And 60 degrees is pi divided by 3. So we'll try to use these difference formulas to come up with these angles that we are familiar with. And 60 degrees, of course, is pi divided by 3. And we'll just go into 4 pi over 12 since we see that pi over 12 in one of these problems. But we could get a common denominator with any problem. Okay, so let's begin with the sine of 15 degrees. We do know that that is equal to the sine of the sine of 45 degrees minus 30 degrees. And both of these are familiar, okay? So that's equal to the sine of 45 degrees multiplied by the cosine of 30 degrees minus the cosine of 45 degrees multiplied by the sine of 30 degrees. So this is the difference formula for the sine right here. Okay, so we'll take each one of these, the sine of 45 degrees, square root of 2 over 2, cosine of 30, root 3 over 2, cosine of 45 degrees, root 2 over 2, and the sine of 30 is 1/2. So here we have root 6 divided by 2 minus root 2 divided by 4. And that should be 4. And now we have root 6 minus root 2 all over 4. Okay? Let's try number 2. We have the cosine of 7 pi over 12. So looking over here, we could see that 3 pi over 12 plus 4 pi over 12 is equal to the cosine of 7 pi over 12. So we could say that this is equal to the cosine of 3 pi over 12 plus 4 pi over 12. Now this is our sum formula for the cosine. So we will take the cosine of each angle and then subtract multiplying by the sine of each angle. So this is equal to the cosine of 3 pi over 12 multiplied by, and we could write this as pi over 4 plus pi over 3. And I think I'll just try to work across here. It might make it a little bit easier. And that's equal to, and again, we will have the cosine of each of these angles multiplied together. Whoops, that should be a 3. And now we have that opposite sign. If you remember right here, have that negative if it was a sum, minus the sine of each of those angles. Okay, and that comes out to be root 2 over 2 multiplied by a half minus root 2 over 2 multiplied by root 3 over 2. And I'm really not doing a very good job here. Not doing a very good job at all. I think it's just easier to do this. And now, multiplying those together, we can come up with root 2 over 4 minus root 6 over 4. We come up with root 2 minus root 6 all over 4. Okay, how about the tangent of 75 degrees? We should be thinking about 35 degrees. Excuse me, we should be thinking about 45 degrees and 30 degrees. Okay, so we could say that that's equal to the tangent of 45 degrees plus 30 degrees. And now we just learned about that quotient. So in the numerator, we will have the tangent of 45 degrees. And this is the sum. And as you can see, we're going to have this plus sign, which is the same in the numerator, plus the tangent of 30 degrees all divided by 1 minus, and then we will have the tan of each, the tangent of each one of those angles multiplied together. The tangent of 45 degrees multiplied by the tangent of 30 degrees. Okay, so now the tangent of 45, of course, is 1. And then we have root 3 over 3 for the tangent of 30 degrees. And then we have 1 minus root 3 over 3 for that denominator. Now that's a complex fraction, and we'll go ahead and multiply the numerator and the denominator by 3. And we end up with 3. Let me raise that up just a little bit. And that's equal to 3 plus root 3 divided by 3 minus root 3. And let's go ahead and multiply the numerator and denominator so that we can create a difference of squares. So we'll multiply the numerator and denominator by 3 plus root 3 divided by 3 plus root 3. And we have 3 plus root 3. Why don't we just go ahead and multiply those out? The numerator is 9 plus, and we will have 6 root 3's because we'll have 3 plus another 3 root 3's, and then we have a plus 3. And multiplying that denominator, the difference of squares is just 9 minus 3. So we come up with 12 plus 6 root 3 all over 6. Let's factor a 6 out of that numerator. And we end up with 2 plus root 3. Okay, let's look at number 4. We have the sine of the opposite of pi over 12. And we should be thinking about this 3 pi over 12 here. I think I can change colors here to kind of keep it consistent. We have 3 pi over 12, and we have 2 pi over 12. Or we have 4 pi over 12. So we could take 3 minus 4 pi over 12 and come up with that negative pi over 12. Let's give that a try first. So here we have the sine, and we said we would take 3 pi over 12 and subtract 4 pi over 12. And that would give us that negative pi over 12. Now, we can simplify that to the sine of pi over 4 minus pi over 3. And if you can see here, that is the difference identity, the difference formula for the sine. So again, we have this formula here. So we'll have the sine multiplied by the cosine of each one of those in that order. So we'll have the sine of pi over 4 multiplied by the cosine of pi over 3. And now we're going to keep that same sign. And we'll have that minus. And now we'll have the cosine of pi over 4 multiplied by the sine of pi over 3. And we can just fill those in. We have root 2 over 2 multiplied by a half minus root 2 over 2 multiplied by root 3 over 2. So now we have a common denominator of 4, as you can see. We end up with root 2 minus root 6 all over 4. Okay, let's take a look at this next one. As you can see, we have the sine and the cosine alternating. So let's highlight these angles. So we have 65 and 20, and then 65 and 20. And as you can see, we have the difference. So if we can come up here, we can see that that's the sign of a difference right here. Okay? And so that's going to be simply the sine of 65 minus 20. So this is actually equal to the sine of 65 degrees minus 20 degrees. And that's equal to the sine of 45 degrees. And that's equal to root 2 over 2. So we can use these difference and sum formulas to also simplify. So using the final product of that formula. Okay, we can see that this tangent here are two angles. You can see our angles, 7 pi over 9 and pi over 9, and here they are again. And we see that minus in the numerator. And that means we have that subtraction in the numerator again. If you remember, here is that formula. So it's the tangent of the difference of the angles. Okay, so we can say that that's equal to the tangent of 7 pi over 9 minus pi over 9. And that's equal to the tangent of 6 pi over 9 and that's equal to the tangent of 2 pi over 3, and that's equal to the opposite of root 3. Okay, let's take a look at number 7. Find the exact value of the cosine of alpha minus beta. Okay, so we have alpha and alpha is in quadrant 4, and then we have beta, and beta is in quadrant 2. Okay, so as you can see, both of those are shown here. There's alpha and there's beta. Okay, so let's first write our formula for the difference formula for the cosine, and we have the cosine of alpha multiplied by the cosine of beta, and then that's the sum. Remember, we have the opposite of the sine of alpha multiplied by the sine of beta. Okay, so what do we have to do? We have to find each of those using these triangles. So let's go ahead and write that over here. We can see here, if we call this value x, that x squared plus 2 squared equals 5 squared. And so x is equal to root 21. Now, let's go ahead and take care of the next triangle, and then we'll be ready to go. We have that 5 squared plus 12 squared is going to be equal to that hypotenuse squared. I'll just use a z, but you could even use x if you want for your unknown. So we have 25 plus 144 equals z squared. So we have 169 is equal to z squared. So obviously z is equal to 13. Okay, so what do we have here? Well, if we need the cosine of each one of these angles and the sine of each one of these angles, why don't we go ahead and find that? The sine of alpha and the cosine of alpha. So the sine is the opposite, which would be 2 over that hypotenuse, which is root 21, which would be 5. And that would be a negative because in quadrant 4, the 2 will be negative. So the sine, is negative in quadrant 4. Now the cosine will be positive, and that's the adjacent, which is root 21 divided by 5. So we do have to watch our signs there. That's because we're in quadrant 4. Okay, now let's go ahead and take a look at this next one. We'll have the sine of beta and the cosine of beta. And looking at both of those, these are both going to be positive. We should have probably put a negative there, and that's a positive. Okay, so both of those are going to be positive. The cosine will be negative. So I'm going to place that negative and get ready to go. So the sine is the opposite over the hypotenuse, and the cosine is the adjacent over the hypotenuse. Okay, so now what can we do? Now we can go ahead and use our formula, which this is equal to negative 5 over 13. I'll go ahead and write the first one there first. That's equal to root 21 over 5 multiplied by a negative 5 over 13 plus a negative 2/5 multiplied by 12 over 13. And so if you multiply this out, you'll get a negative 5 root 21 minus, and these denominators are going to be the same, 24 all over 65. Okay. Okay, now we're going to use the sum and difference formulas to verify identities. So now we're given the sine of a difference equals the cosine of x. Again, we're going to begin on that left-hand side only, and we will write that the sine of x minus 3 pi over 2, and we'll use that formula. We'll have the sine of x multiplied by the cosine of our other angle, 3 pi over 2, minus the cosine of x multiplied by the sine of 3 pi over 2. And that's equal to the sine of x multiplied by 0. Cosine of 3 pi over 2 is 0, minus negative 1 multiplied by, and I can put the cosine of x first, cosine of x multiplied by -1. Well, that's just equal to 0 plus the cosine of x. And we come up with the cosine of x. Okay, let's take a look at number 9. Again, we're working with the left-hand side. Okay, and so as you can see, we have the cosine of a sum. And when we have that, we will have the cosine of x multiplied by the cosine of y minus the sine of x multiplied by the sine of y. Now we'll use this second identity, minus, and this minus is this minus. And now we have the cosine of a difference. And so we're going to need to use parentheses so we can distribute that negative sign. Cosine of x, cosine of y, plus the sine of x multiplied by the sine of y. So let's go ahead and distribute that negative. I'm just rewriting, whoops. So minus cosine x, cosine y, minus sine of x, sine of y. And as you can see here, these terms will cancel, and we actually have two identical terms. So we have -2 sine of x, sine of y. And that is, I probably shouldn't have put that there, that is equal to what we have on the right-hand side. Okay, let's take a look at this number 10. We have the product of the tangent of a sum and the tangent of a difference. So we're going to work that left-hand side, and we're going to take each one of those formulas and multiply them together. So we will have, let's work on the tangent of a sum. We have the tangent of x plus the tangent of pi over 4, all divided by, and that's 1 minus the tangent of x multiplied by the tangent of pi over 4. Now here's that product. So we actually have this multiplied by, and now we have the tangent of a difference, which is the tangent of x minus the tangent of pi over 4, all divided by, so it's almost like these signs have been switched. 1 plus the tangent of x, the tangent of pi over 4. Now what are we going to do with all of this? Well, the tangent of pi over 4 is just 1. So this works out nice that we have the tangent of x plus 1 divided by 1 minus the tangent of x. And if you want, you can take like a lighter pen or something and just make note that this is equal to 1. Whoops, I really didn't want to use anything that dark. This is equal to 1. Well, that's just, yeah, that's what I wanted. Okay, so now we have that multiplied by the tangent of x minus 1 divided by 1 plus the tangent of x. And as you can see, these two terms cancel, and these two terms cancel. So we actually have this equal to a negative 1. Actually, before we do that, why don't I show you this? Let's keep this just like this, because that's something we want you to be able to see. That numerator is the opposite of 1 minus the tangent. Why don't I write it to the right? Okay, I think this is important enough to say that this is equal to the opposite of 1 minus the tangent of x divided by 1 minus the tangent of x, rather than just saying that that's equal to negative 1. Okay, and I'll just make a little note that a minus b is equal to the opposite of b minus a. Okay. Okay, so let's take a look at number 11. We have the sine of a sum, and that's divided by the product of the cosine of two different angles, those two angles that we are using there in the numerator. So just working with that left-hand side, we'll use our sine of a sum property, the sine of x, cosine of y, plus the cosine of x multiplied by the sine of y, all divided by the cosine of x multiplied by the cosine of y. Now, what we can do here is we can share this denominator. So really, this is what we have. So lots of algebra, and that's why it's really important to have algebra before this course. And as you can see, these cancel. So I always look at this. I might say to somebody, share the denominator, but each one of these terms has this denominator. Each one of the terms in the numerator share that denominator. So that is actually equal to the sine of x divided by the cosine of x plus the sine of y divided by the cosine of y. And that worked out nicely. We have the tangent of x plus the tangent of y, and that is what we were trying to find. Okay, so now we will end this section with writing a sum of the sine and the cosine of x when they have coefficients in front of the term. So we will be writing a sum of a times sine of x and b cosine of x as a single term. And this formula is called a reduction formula because it reduces the sum of two trig functions into one term. So if you can see, for all real numbers, a and b, if you have a sine of x plus b cosine of x, you will have some constant k times the sine of x plus alpha, okay? And now we have a formula for k, and we have where alpha satisfies both of these, okay? So let's just try this. I think it's easier to work this. Give it a try first, and then we can go back and look at that reduction formula. So as you can see, I'm going to just go ahead and write this out. And we want this form, okay? And so once we have this, what do you notice? You notice that A is equal to 11 and B is equal to 60, okay? So we're going to solve for little k, and k is equal to the square root of a squared plus b squared. And that's equal to 11 squared plus 60 squared. And that comes out to the square root of 3721, and I hope you have your calculators out because that is equal to 61. So that's what k is equal to, 61. So now let's go ahead and find the cosine of alpha. Let's see if I can bring this up just a little bit. Yeah. Bring this up just a little bit. Okay, so we're going to come up with the cosine of alpha and the sine of alpha, okay? So we'll have the cosine of alpha is equal to, as you can see, A over K, and that's going to be 11 over 61. And the sine of alpha is B over K, and that's equal to 60 over 61. So now what can we do? We can now see what alpha is equal to. So we can actually say that alpha is equal to the cosine inverse of 11 over 61. And if we go ahead and do that in our calculator, we come up with 1.3895, and we were asked to round to 4 decimal places. So alpha is equal to, or we'll go ahead and say approximately equal to, since we're rounding, 1.3895. Okay, so let's think about this. We are going to be in quadrant 1 because the cosine is positive. So we are going to be in quadrant 1. So now we can say that this is equal to 11 times, well, we wrote that already, so we can now use this formula right here. Our K was 61, and now we have the sine of x plus alpha. Okay, let's look at number 13. Check your answer to exercise 12 by using the sum formula for the sine. So we will take this 61 sine of x plus 1.3895 and say that that's about equal to 61, and we're going to go ahead and use the formula for the sine of a sum, and that's equal to the sine of x cosine 1.3895 plus the cosine of x multiplied by the sine. of 1.3895, and that's equal to 61 sine of x cosine 1.3895 plus 61 cosine of x sine 1.3895, and that's about equal to, so we are just coming up with 61 multiplied by that cosine, 61 multiplied by the sine, and we come up with 10.9986 sine of x plus 60.0003 cosine of x. And that's about equal to 11 sine of x plus 60 cosine of x. And that concludes this section.